This video contains the solution for all the parts of number 2 from the 2008 AP Calculus BC free response portion of the AP test, Form B. So let's see what we have here. We are using our calculator here if we like, and I think we will like on this problem to do that. For time t greater than or equal to 0, let the rate, let's see, I'm jumping the gun here, r of t, I'm thinking that's a rate because they're using r, but let's see what they say. R of t equal to this, represent the speed in kilometers per hour, so that's a rate, at which a car travels along the straight road. So this is the speed of the car. Notice they said speed and not velocity. We'll see if that matters. The number of liters of gasoline used by the car to travel x kilometers is modeled by g of x. Notice the difference of the variable here. This is a function of time. This is a function of distance. Number of liters of gasoline is modeled by this. Notice that that's not a rate. That's actually the number of liters of gasoline. All right. So how many kilometers does the car travel during the first 2 hours? Well, we've got its rate, so if you want to know how many kilometers it traveled, then from 0 to 2, we want to know the integral of the rate will give us the displacement, and since this is speed, we should, I guess, figure that's always positive. You could put absolute value signs around there if you were really nervous, or you could look at the graph, see that it's always positive, and that should give us, putting that in your calculator, which you should try, and make sure you get this answer, a displacement of 206.370 kilometers. 206.370 kilometers. I guess it should be a reasonable answer. I mean, we're talking about driving a car for 2 hours. That would be an average speed of near 100 kilometers per hour, which is 60 miles an hour-ish. So that seems pretty reasonable for an answer. Part B, find the rate of change with respect to time, the number of liters of gasoline used by the car when t equals 2 hours, and indicate the units of measure. Well, let's see, we want the rate of change with respect to time of the number of liters of gasoline used. So we want gallons per hour. Hour is the unit of time that I'm using because that's the unit of time that I have here. Now the problem here is the gallons function is a function of distance, and this is a function of time. So let's write those out and see what they are. R of t is itself a derivative, which is dx dt, right? That's a speed. So think about that for a second. R of t, it's the speed function, so that's the derivative of x with respect to time. And if we want to get into gallons per hour, the derivative of the g function that they gave us, that would be dg, the dg dx, right? And what we want is gallons per hour, or in other words, dg dt. We want gallons in time. So looking at what we have, or what we can get, they gave us this function. It would be easy to get this one by taking the derivative of that. So multiplying these together, what we want, dg dt, is equal to dx dt times dg dx. And those would cancel out. So I need to find the derivative of this, multiply those two together, and then plug in time equals 2 hours. Now the trick there is, before I can do that, I can't plug time equals 2 hours into this derivative because it's not a function of time. So I actually have to put the t in here and figure out where we are. So let's go through that process and do that. So let's see. At t equals 2, dg dt is equal to dg dx, which I calculated to be 0.05 times 120. That's the value of dx dt, right? Plugging the 2 hours into this, and that gives us a value of 6. And what are we talking about here? 6 gallons per hour. Oh, and it's the number, look at that, they use the G function, but it's liters, so how embarrassing, how American of us. But it's liters per hour, and they did give those as the units in the problem. So 6 liters per hour. It would make sense that if they're going to talk about kilometers, that they would talk about liters. And make sure you figure out where that value comes from. Please go through that process to find that and to use the equations they gave. And in part C, the last part, they ask us, oops, wrong page, sorry. Here we go. How many liters of gasoline have been used by the car when it reaches a speed of 80 kilometers per hour? Well, if we want to know the total amount of gas used, that's an integral, right? That would be the integral of the rate of change of the gas function. But we don't know, the problem here is we don't know the this is a speed, and the fuel, how many gallons that we've used, is a function of distance. So what we need to do here, actually scratch that, we need to say, let's see, if it's going 80 kilometers per hour, 80 kilometers per hour, that's a rate. And we have the rate function here. So when does that happen? Let's see, we could solve for time. 20. And that will give us a time. Let me check my work there. Let's see what we have. Solving this equation with a calculator, you should get a time of 0.331 hours. Take a minute to make sure you can do that, subtract that to the other side, and just find the 0 of that. That happens at t equals 0.331 hours. And now we need to know the total distance traveled. So how far did we go from time 0 to this time? Well, that is the total distance traveled from time 0 to the time that we just found, that's where it hits 80 kilometers per hour, of the same rate function. Remember, this is the same exact thing we did in part A, but they gave us this number. That was for the first 2 hours, and now we need to know when it hits 80 kilometers per hour after that much of an hour. So same exact setup. And putting that in the calculator to figure out how far it went. It was 10.794 kilometers. And then, now that we finally have a distance here, I can plug that into the G function, which tells me the number of liters of gas, I guess that's what G stands for, used at any given distance. And that is 0.537 liters when we plug this distance into the G function. So that's a little convoluted. I think the way that we had to use the chain rule here, really, to do that, and then use both functions to figure this out. There's a lot of thinking about units. Definitely not just a rote memorization, oh, I've done this problem before. You really have to think about what you're given and what you're trying to find, what the units are. All those things will help you get to the right answer.